Hello, can you hear me? Yeah, hi. First of all, welcome to this session. Again, I'm Uday Teneti, and I'm with GE Digital. So first and foremost, I want to ask, how many of you know about GE Digital? Quick raise of hands. Okay, more than definitely what I thought. So for others, I'll just give you a quick overview on what we do from a GE Digital perspective. And essentially, I'm sure all of you know about GE as the big company, right? But again, GE Digital is a new incarnation or a new entity that we have created in GE end of last year. So we used to be called GE Software, and we started as a COE or a Center of Excellence 5 years ago. And then we morphed into GE Digital, which is a new P&L in the GE suite of, again, different industrial businesses that we have. Most of you, again, probably are aware of GE Transportation, GE Aviation, GE Energy Management, and so on. And now we have created this new entity called GE Digital, right? So which is a P&L, but it's an interesting P&L. It's a vertical as well as a horizontal. So we work with, again, new companies or new industrial verticals that GE traditionally doesn't work with. And then we also support the existing GE verticals, like our customers in transportation, aviation, energy management, and so on. So I've been with GE for the last 2 years, and I lead a couple of initiatives at GE. One, I manage the strategic engagements, which is essentially working with our customers, different kinds of various customers. And then I also lead an innovation center at GE. We call it the Design Center. Okay? So a quick show of hands again, how many of you are from industrial companies? Okay, a few of you. That's great. So I'll talk a little bit more about our platform as well that we have created called Predix. And essentially it's a purpose-built platform that we have created for industrials, right? And I'll talk a little bit more about that. So again, these companies that I have on this slide are not new, right? You all know about these companies. And if you look at, again, the business models, if you look at Airbnb or Uber, for example, one way to look at it is these companies have created a big ecosystem. And again, new business models and new ecosystems. But then the way we look at it is slightly different. The way we look at it is these companies don't own any assets, right? Like Airbnb doesn't own any real estate, or Uber doesn't own any cars or automobiles, right? But then what they have done is essentially looked at inefficiencies in these assets. There is a lot of underutilization of these assets, and they created a new business model on how do you optimize these unused assets, right? The same methodology we have been thinking about in GE as well, started about 5-6 years ago, which is GE creates anything that moves, rotates, right? We create rotating equipment, and we've been doing that for 130 years. I mean, there is a reason GE has been in existence is due to innovation. So what we saw is a need to innovate where GE has all these assets. It could be gas turbines, it could be your jet aircraft engines, or it could be your locomotives. But then, how about a new company coming in, a startup, let's say, and disrupting this whole ecosystem? And you have all these assets, which are again we have $1 trillion of assets under management, $1 trillion, right? So think about a situation where a new company comes up and says, there are all these inefficiencies, and then I'll provide a new business model to capture that value, right? And we wanted it to be GE rather than some other company taking over that. So we started on this journey with that intent. And again, Apple is an interesting example where when they started with iOS, all they had was very few apps that they developed, right? Less than 10. And then the whole ecosystem created the different apps, right? So we looked at a similar model as well as we developed a platform for industrials. And I'll talk a little bit more about that. So again, different numbers, but the main idea here is that there is a lot of growth in the industrial assets. If you look at it in the smart metering space, we see again by 2020, which is not too far away, more than 1 billion pieces of equipment growing. So, and again, different numbers, in millions and billions, but the whole idea is that even with GE, we generate 1 million terabytes of data just with GE equipment, right? Everyone talks about big data. There is a connotation for that for GE as well. But then, do we store all of that today? Not really. Do we need to store all of that? Not really. But there is a good chunk of it that we need to store and analyze to get those additional capabilities and insights for our customers. Okay. So the journey for us started about 5 years ago in 2011, where we created GE Software. And GE Software was, again, as I said, a center of excellence under GE, starting to experiment with big data and analytics initiatives. And we are headquartered in San Ramon. For those of you who do not know, it's in the East Bay, essentially. And here, this was a decision taken by the board with $1 billion of investment. So huge investment, and the main intent was that a lot of computing, even when you look at companies like Cisco and others who are in the router space, their compute storage, again, the intelligence is moving on to the software, right? So the similar story we see where we have the physical equipment, but there is a lot of compute and analytics being moved on to the software side of things. And the machines themselves are getting a lot more brilliant, even in GE, where today if you take a sensor which does humidity and temperature, you can buy that for $1.50, right? Which was not the case even 5 years ago. So the sensoring technology has become a lot more efficient and a lot more cheaper, that you can embed them in all kinds of equipment. And what that means is a lot of data being generated. And again, like everybody else, we have some numbers as well. But again, for GE, the data that we capture is a little different, where if you look at like a Facebook post or a Twitter feed, it might be okay if you lose a Facebook post or a Twitter feed. But for GE, the events coming off jet aircraft engines or an MR machine are a lot more critical, and because you cannot have those assets fail, right? So there's a lot more importance that we assign to these events coming off. We want less of those events coming in. Again, if you are in consumer space, you want more of that, right? So it's a little slightly different. But all this doesn't mean anything unless you can surface those insights to the people at work. So today, our workforce, even in GE, we have about 30,000 field engineers, and they're used to devices like this one, right? So how do you surface your insights in real time or in near real time to them in those kinds of interfaces? So that's what we are looking at. So again, in GE, what we call is the power of one. So again, if you can change or move the needle by 10%, that's awesome, great, right? But what we believe is, even if we can move the needle by 1%, it still results in billions of dollars in revenue or cost savings for our customers. For example, in transportation, the freight utilization, right? There is, if you can improve that freight utilization, it results in, again, billions of dollars. Now, it could be 27 billion, or it could be $1 billion off here and there. But the main intent or the main point is that there is big money to be made in the industrial space. So that's our focus again. If you look at the tagline that we have now for GE, we used to be called an industrial company. Now we are a digital industrial company. So that's our new tagline, which is we're not going away from industrial, but we are embracing digital in everything that we do. And I'll tell you a little bit more on what that means. In healthcare, again, you'll see predictive maintenance. There are, again, the keynote speech today was very interesting on the genome sequencing and the kinds of initiatives happening there. We see a similar pattern in healthcare with GE as well, and we launched something called GE Health Cloud, right, to take care of the challenges and opportunities in the healthcare sphere. And in power, again, not to mention, most of the power plants, if you think about them, they have been set up 40, 50 years ago. And there are a lot of inefficiencies in the whole operations. So if you can streamline those and make them more efficient, there is, again, a lot of revenue to be generated and more cost savings as well. So the way we did it again is we initially started doing it for GE. We said, let's try it for GE. So GE, as many of you might know, we are again, last year we generated about 120 billion in revenue, and then with the Alstom acquisition, we have about 330,000 employees now. So huge. We are in 170 countries. So we have 400 plus factories. This is a good test bench for us, right? If we can do things for ourselves, there is a lot of potential savings inside the company even before we do anything else outside. So we started doing it for ourselves, optimizing our plans, optimizing our factories, and our internal processes, right? So if you think about that, if you look at even our aviation business, it's again, $40+ billion of business. It could be its own company, right? Transportation could be its own company, and so on. So what that meant was we had a lot of instances of software sitting in different industrial verticals. You would have like 5 Teradata instances in one, 5 different Oracle instances in a different one. They wouldn't talk to each other, right? As you can imagine. So what that meant was we were not able to streamline all the data sets across the company, leave alone the customer data sets, right? So we had to, again, create all these efficiencies within the company before we started doing it for our customers. So we started on these productivity initiatives. The first one we did is called digital thread, which is GE has been doing equipment, rotating equipment, manufacturing it for 130 years. So we know physical science, we are good at that. But then when we sell that equipment, we provide services on top of it. And there are a lot of maintenance records that we collect, right? So now we are connecting, again, that as well. And when, again, the equipment goes back into the field, initially we didn't know how it was operating in the field, a gas turbine or a jet aircraft engine, right? So we are connecting that now as well. So what that means is we are connecting the data sets from the design to manufacturing to maintenance to operations. And what that helps us is to feed, again, if we see specific issues for specific jet aircraft engines, then we can get those insights back into our manufacturing process and optimize those. That's one. And then using that, we are able to provide additional solutions to our customers using, again, software and analytics. Okay? Different kinds of use cases. So we did that, and we were fairly successful. And there is also a big initiative which we call as digital twin, which is, as you might have heard from some of the speakers today, again, as a cluster, you can look at the anomalies, and it's easy to do that. But then per engine or per asset modeling is critical for us. Again, the interesting parallel to that is if you look at your automobiles, right? Your cars. A few years ago, you would go do an oil change every 3,000, 5,000 miles. Now it's gotten a little better, where based on the car that you drive, the kind of car you drive, you have a certain kind of maintenance that you need to follow. But it's not still to the extent where per asset, based on your driving behavior, can we predict and tell you this is how you need to maintain, right? This is going to be your flow. Now that your driving pattern has changed, this is going to be your updated flow, right, or a maintenance flow. It's not there yet. And that's exactly what we are trying to get to for all our equipment. Okay? This we call as digital twin, which is a digital manifestation of a physical asset. Okay? And I'll talk a little bit more about that. And again, we did that, and then we started doing different applications for our customers. Once that was fairly successful, this was about 3 years ago, this year we went on an interesting initiative, which is to do all this, we developed a platform called Predix. Predix, as we call, is the operating system for industrial internet, and we have put it back into the open, where anyone can come and develop applications on top of this platform now. Okay? So Predix, again, I don't know how many of you have heard of it before, but if you go to predix.io, we have all the documentation, APIs, everything available there. So anyone can come in and they can develop apps on top of it. but it's custom built and purpose built for industrial customers here. So what we have done is we have created different asset models, which is, again, it could be GE assets or non-GE assets. And for us, it was really important where when we are working with optimizing a power plant, they might have some GE equipment and GE assets and many non-GE as well. So we need to understand both to be able to provide that optimization for the power plant. So we have created some generic asset models to be able to provide that. And also different kinds of capabilities for data science, primarily targeted for industrial data science, right? And then again, different capabilities there, but the way it helps is to provide that monitoring and diagnostics for our customers, as well as for how do you improve the asset life cycle, right? We know the physical science because we created that equipment, but then how is it operating in the field today? What temperature, pressure, humidity is it operating today? And based on that, we can take those learnings and fine-tune the parameters using software and analytics. To give you an example, for example, in renewable space, you have all these windmills, and traditionally we would sell the wind turbines, and then we would provide the maintenance for those. But now what we have done is, based on the different conditions that we have seen that the turbines operate in, we have again optimized the software where based on the wind conditions you can change the pitch of the blades to get more wind. But then if you do that for a single wind turbine, it causes a lot of turbulence. So you have to optimize it as a farm, right? So we have created a solution called PowerUp, which essentially helps you do that. And a lot of predictive maintenance capabilities. If you have downtime for any of the jet aircraft engines, then it's again millions of dollars of lost revenue for the aircraft carriers. So how do you provide that predictive maintenance capabilities? And we have developed solutions called flight efficiency services in aviation, just to enable to do that. So this is our platform architecture, a quick overview on this. So if you look at from the left, the picture shows again a windmill, but it could be any rotating equipment. And what we have done is, for Predix, we also created an edge computing device there. It's a box essentially where Predix software runs. We call it the Predix machine. Using that, you can get the data from the different equipment, and then you can provide some quick lean analytics and provide quick insights to the equipment. But most of the data is actually shipped to the cloud where Predix sits. And we have two models there. One, we use some public cloud providers, and also the other is GE has its own data centers as well. So for our large customers who care about the SLAs or the security needs that they have, then we rely on our GE's data centers. Only then we can promise those SLAs for them. Okay. And it's built again using the Cloud Foundry framework. So it's open architecture, and we have exposed all the services through microservices. And we have created these catalogs. We have asset catalog where there are different asset services. You have an analytics catalog and so on. To give you an example of analytics catalog, we have an anomaly detection algorithm there. And initially we use that for our own business in aviation, where if you look at the flight patterns, you see a lot of anomalies on how the engines deteriorate over time and the class of engines. And we use that anomaly detection to find those patterns. And we use the same anomaly detection in healthcare, which is a very different field. Right? In healthcare, we have created a product called Denials IQ, which essentially when our healthcare providers submit claims, many of those claims get denied. But there is a pattern to that. And using the anomaly detection there, we isolated again those patterns and provided those insights to our healthcare providers. Right? So it's again generic in nature, but then purpose built for all our industrial customers. Using those services, we have built apps, but now that the platform is available out there in the open, our partners are continuing to build apps, as well as our customers are starting to build their own apps as well. GE still has, again, a services wing which helps build apps, but it's mostly driven by our customers and partners building it for themselves or for their customers. So, diving a little bit into the digital twin concept, again, as I touched upon, when you look at, this is an example of in aviation, when you look at, again, the cumulative distress, right? The distress that these engines go through in the various segments. If the engine is flying over Middle East or in Africa regions, there is fine sand that gets into the shroud, it heats it up and corrodes it. So there is a pattern to that. In some other countries in Asia, there is a lot of pollution and there is a different deteriorating pattern. But if we can isolate those, then we provide that specific maintenance schedule for those class of engines or for those aircrafts which have flown in those regions, right? So we are getting to that per engine, per asset modeling there using this digital twin concept. So instead of going back to the asset every time, we are modeling those assets, the physical identity of those assets digitally, and everything that happens through that. It's like, your history is tagged per that asset digitally, right? So that we can use for forecasting much better. And the digital thread, I won't go a lot more into this, but essentially from engineering perspective, when we started this, we even created a new class of turbine which usually takes 15, 20 years, right? We, again, reduce the time 2x, even from a development perspective, because we are connecting all those assets and the data sets. And we have this big initiative called Brilliant Factories, which is how do you make the factories brilliant? And we started doing it for GE initially with different pilots. Again, from a services perspective, using sensor data and analytics to provide those insights to the field engineers. So this is an example of a plant in Greenville, South Carolina, where again, we started this journey of 16 Brilliant Factory pilots, and for this one, we were able to provide 25% more productivity, right? Again, just in this plant alone. It's a manufacturing plant. And for new product innovation, when we want to create a new product, we reduce the time, the cycle time, by 30%, which is huge for GE. Okay. So the way we are doing it is we are combining the physics, the physical knowledge and the physical science with the data and analytics, right? That's the fusion that we have seen in the industrial space giving the most value for us. One, again, you've seen the different sessions, combining the data, the statistical knowledge, but for us, it's also the physical science. So combining these three, providing these capabilities and insights for our customers. For aviation, for example, the time on the wing is more important. The more they can fly, it's more revenue for them. If you have an unscheduled maintenance, your aircraft is down, it leads to a lot of, losing the revenue. And all the software and analytics that we provide need to be at a point where the engines or the equipment is still reliable, right? You are not running it to the threshold where you have more failures. It has to be very reliable there and available. So fuel is not too much of an issue today, as you know, but still 30 to 70% of the airline operators' operating expenses are fuel costs. So if you can reduce that, it's a big savings for them. And needless to say, reducing the repair and overall expenses as well. I won't go into that one. So again, look at a different industrial vertical, transportation. I don't know how many of you know, but the average speed for a locomotive, right, running in the United States, it's about 18 to 20 miles an hour, a freight train. So you can imagine if you can change that by 1%, there is a lot of revenue that can be made there. So most of the time is spent, believe it or not, in the yard. We call it the dwell time, where you are waiting for essentially some other locomotive to pass by, or based on the schedule, and you're waiting there for different reasons. So if you can optimize the operations, the yard operations, there is a lot of savings and new revenue to be made there for our customers. So that's one application that we focused on. And then we provided, when we have something called, again, brake bleeding, which is you have to bleed these brakes periodically. the locomotive could be flying or running through in the Midwest or in Texas. It could be in remote areas, and you might have to do these operations late in the night. So what we have done is we have started these pilots in automating those using robotics and then software and analytics. So a robot is essentially sitting in that locomotive, and then when you need to do this operation, the robot gets down, inspects it, and then does that operation, right? We are trying to automate all this using software analytics and also using robotics in this mix. So what we have done here is different kinds of apps that we have created, just like your Apple iPhone, but for industrials, and then combining it all that on this Predix platform. So in renewable space, I touched upon this when we provided this, again, new capability for our customers there. The 3 questions that they asked was, I want to generate more revenue using the equipment I have. I don't want to buy more or new equipment. And then do it such a way that it's reliable. And the third thing that they asked is, show me that it's actually working, right? It's not a software solution where take this solution and hope you get the value. Here, the use case was, they said, show me the value, right? So we created this solution called Power Up, where it's more on it's a new business model that we have created, which is on a profit sharing model. If you get more energy, then we get a cut. If you don't make anything, we don't get anything. So look at that. We are sharing the risk profile with the customer, so which was new for GE as well in this model, rather than just selling a software application and then monetizing that. In oil and gas, which is again a slightly different industry, here we worked with a large pipeline operator initially, and for them it was very critical that if you can detect any leaks in those pipelines, and those leaks are close to, and those pipelines are close to an hospital or a school, it's a lot more important for them to get to it right now versus a pipeline out there in the boonies. So we worked with this customer and used again data from the different sensors, and we also have this equipment that goes through in these pipelines to look at the pressure, humidity, and so on. We collected the data of that. And what we helped is initially providing even the visibility to the different assets. So when you have pipelines, something that you may not know is they run through the whole United States, but there are chunks where this piece is owned by this pipeline operator versus that piece is owned by a different pipeline operator. It's not an end-to-end story everywhere, right? So they care about where are their pipelines essentially. You want to provide those analytics, right? As basic as it sounds, but having that view, holistic view on where your pipelines are. And then the next thing that we did was then providing that capabilities of predictive maintenance. Okay? So chunk by chunk essentially. Again, all this that you see here are different apps we again developed with our customers using the platform as well. Now there is a very interesting shift that we did in GE, which was the standard GE industrial verticals. Definitely, we know that oil and gas, transportation, energy management, healthcare, we know that very well. But now using software and analytics, we are working with new sets of customers. For example, we are working with a few customers who provide elevators, right? There are only a few who manufacture elevators, and we are working with a couple of them, which is a very different industry, but still it's all assets. Today what happens is you have a periodic maintenance for your elevators, and then when something breaks down, then they get a call saying, I need some help, right? From the perspective of the manufacturers or the operators of all these elevators, they have to keep their staff on hand, not knowing when an issue might come up and where. So instead of that, we said, can we be more predictive in nature? See if something's going to break, use data and analytics again, and then provide this predictive maintenance. So that's the game we are in here. So we started with elevators, and then we again are working with different companies like agribusiness, manufacturers, equipment manufacturers, and so on. This one is an interesting one where GE started with a light bulb. With Edison, we started with a light bulb. And guess what? Light bulb has become a commodity. There is no money to be made there. You might probably lose more money selling those. So what we did is, again, you have two choices, right? Either you exit out of that business or you do something very innovative. So we chose the later path and we said, let's do something interesting. And instead of envisioning it as a light bulb, we started looking at it as a platform where we can do a lot of interesting things. So we put in the Predix machine component there. We embedded that light bulb with cameras. We put in sensors. We put in a microphone. And now we are able to do different kinds of analytics. So at the base, it provides that LED lighting, so it provides that energy savings. But then we are providing new capabilities working with cities like City of San Diego, Jacksonville, and a few others, providing pedestrian safety applications, developing applications to help with parking violations, improving the traffic congestion patterns, if there is a gunshot, where and how it happened, different kinds of use cases. And the way it's been efficient is you have light bulbs everywhere, right, even in this building. So you can embed these anywhere you want without having to have a new space, creating a new space to embed these technologies, but they come equipped with the light bulb, right? And we created this business called Current Now, which has lighting, battery storage, and solar. So 3 capabilities into that. So to do all this, we have created a customer collaboration space in San Ramon, and we are replicating that across the world when we are setting up other centers as well. We bring the customers for a collaboration session. We spend 2 to 3 days with them to really understand their business problems and then see how technology can help them get there. So it's starting with the business problem and then see what technology and how do we leverage that. Again, it's a cool environment and a cool working space, but the main intent is using design thinking as one of the methodologies to help deliver that, and also another methodology called FastWorks that we developed in GE. So using this combination of design thinking and FastWorks to uncover the business problems and get to those outcomes. GE is again part of different consortiums. We are one of the founding members of the Industrial Internet Consortium, trying to create common standards, and now there are about 400 different companies with us in that. And there are a few other, we are again in Cloud Foundry and Open Data Platform. The Open Interconnect Consortium is helping drive common protocols and common standards at the equipment level. So it could be an ABB, Philips, or GE, any equipment, but when you are trying to read the data and provide new apps, trying to create common protocols and standards, so it's an even playing field for everyone essentially. Okay. So that was my last slide. I'm happy to take any questions. I think we have about 5 minutes. Okay. Don't go all at once, one at a time. Yeah.
How do you deal with the issue of customers worrying? How do you address the issue of customers worrying about their data being commingled with other customers' data as you're trying to utilize that to make insights?
Okay. So for us, I mean, we made a very clear stance that the customer owns the data. So, we have the similar methodology of a data lake and data privacy, security, all those concerns. And it's the clear value proposition that we have always created is customer owns the data and they can do what they want to do. But if they want us to help provide a common insight across the industry, for example, aircraft engines that others can use as well, then they give us the permission to use that data, right? So that's how we have isolated it. And from a security perspective, we have acquired a company called World Tech, WURLD Tech, about 2 years ago, to provide, again, security all the way from data ingestion to, again, using it at the application level. And again, different partners along the value chain when you're streaming the data as well, and at rest as well as in flight. Yeah, question.
Is there a sandbox available for this platform that we can try or to build something on?
Yeah. So the question was, is there a sandbox or a trial? So yeah, if you go to predix.io, you can actually log in, and then you have a free trial available there where you can start using the APIs and experimenting with it. And there, you can use the services, but then you can write your own services, microservices if you wanted on top of it. Yeah. Go ahead.
Right. So how do you see the open source foundation of it playing with the other people? Of course, GE is this huge, of course, player, right? And now you've open sourced, or you're based on your stuff on this open source Cloud Foundry, and of course there are other analytics and whatnot. But for that certain piece, how do you see the open source interaction going on?
So again, this is one of the early decisions that we have made is we don't want to create anything that's already out there. And also we are not necessarily monetizing on something that's out there in the open source either, right? So that's not our model. The model for us has been use or leverage the technologies. For Cloud Foundry, essentially we leverage Pivotal's stack, right? So we are using that, and the main purpose for us is the different services that we are creating, the microservices. That's where we see the value for our industrial customers. So not trying to, again, monetize on the open source, if that makes sense.
So basically you're monetizing the apps that you write. So just to make sure, so you're monetizing the apps that you write when you bring the customers inside on site, and then you spend 2 days and whatnot. That's where you're actually making the money, right?
Right. The monetization is, just like Amazon or Azure or others. One is platform as a service, software as a service component, plus then these microservices, which essentially provide that value. So monetizing on those microservices. Let's say if some customer thinks values that anomaly detection, right? So there is a price for that essentially. Okay.
First, very nice presentation. My understanding was that GE, the services which you are covering are basically for GE's own business, like their aviation or healthcare area. But I'm also understanding that you provide it as a service. So do you provide it as hosted services for external customers?
That's right. So initially we started it doing for GE, and then started doing it for customers. And earlier this year in Feb, we opened up that platform so anybody could come and build on top of it. So if you go to predix.io, the platform is available for you to sign up, and you can start developing applications on top of it.
And so that platform, the Predix, is more like proprietary of GE, or
so
making it Apache?
We look at it like an iOS platform essentially, right? Where some of the other cloud platforms are anything and everything for everybody, right? So this platform is more purpose built for industrial customers. So you have out of the box, like I said, we provide like asset services or data science capabilities tailored for industrial customers. So that's our value proposition or differentiation.
Thank you.
So is that iOS part completely open source?
Yeah, so the reason I call it the iOS for industrial C is like Android, you can change the operating system. But here, we control that so that we don't have a rogue application coming in and destroying the whole ecosystem. So there are some checks and balances that we do at our end to make sure that it's a stable platform, right? Because it's also hosted on GE's data centers as well for our large customers. Okay. So that's where the iOS model comes in, where there are some checks and balances, but still open that anyone can develop apps and monetize those apps. Okay. Thank you. Thanks, everyone.